Hello, so today we're going to be doing a review over the material we've covered for the past weeks, of mainly fraction, ratio, and proportion, and then we're going to move on into our introduction to algebra. So we're going to go over the basics of algebra, and we're also going to be starting to make ourselves familiar with polynomials. Hi, see someone has logged in. Let's just give it a few more minutes for another classmate to make it in. So remember that the chat box helps me keep track of attendance. So once you do come in, please just type in hi. That way I know, or just go ahead and just send me a private message through text just to let me know so I can count your attendance, because some students are getting it part of a waiver, and I need to record attendance for that reason. Okay. So we're going to start off with reviewing, specifically comparing proportions in different formats. That can be from a word problem, or if the information is presented in different charts that has, like what we saw in the histograms, bar charts, even pie graphs. All of that is going to be taken into account into this little review session. Oh, sorry, my laptop. Okay, there we go. All right, so let's get right into it. So if we remember, a fraction can be a ratio. So if we have a proportion, assumes two ratios are equal to each other or are equivalent. Meaning ratio 1 is equal to ratio 2. And then we were already doing problems where we would solve for an unknown in either ratio. It could have been either numerator, denominator, and then using our rules of PEMDAS, we know, and we will just go ahead and undo any multiplication or division by doing the opposite. Okay, so we remember that. Let's go ahead and erase right here. So let's go ahead and do a problem. So let me organize the information. Sorry, it's very difficult to fit it all into one small board when it's a graphic and a lot of words. However, these are the kind of problems you'll get in the exam, so I need to make sure I do it justice. So let's go ahead and do this. Now, since I am free drawing all of this, we will assume distances to be equal and that it's not drawn to scale. So here we're going to be observing that there's a certain car model. We're going to call it a Model H vehicles. Rate, it's called velocity time graph. Basically, the rate over time. Oh, the rate of speed over time. Speed and velocity, if you're wondering, like, okay, miss, like, are they the same thing? Mathematically, it is the same value. The only difference is, and we'll get into this in the science portion, velocity only has a direction, whereas speed is just a value. So, like, let's say I have a velocity of 20 miles per hour north direction. That's the only difference. So I just said I have a speed. I would just say the numerical value. I wouldn't pay attention to the direction or the vector. Okay, so velocity time graph. Okay. So according to this, so it's more to scale. And they're saying that this vehicle is able to accelerate to 60 miles per hour. Hi, I see another student come in. If I know for those of you who are watching live, if you like come into class a little late, you can just rewind it and you can see me talking from the beginning. Just keep in mind that if you ask a question, I may have already moved on. Go ahead and type, oh yeah, I see someone else who is like, thank you for putting hello. It helps me keep track of attendance. If you haven't done so already, please log in for attendance purposes. So with this car, we're going to assume, or the problem says that it can accelerate, or like at zero miles per hour, it can accelerate up to 60 miles per hour in 8 seconds. So 8 seconds, right? So I'm just going to intersect that. And we're assuming that it does it evenly, at an even rate. We will assume that that is a straight line, even though it kind of looks like a curve. Okay. Now the cool thing is, whenever you get a question and it has like a graph like this, you could cheat by they want to assume like what's the speed at 4 seconds. You could just kind of like eyeball it. Like, okay, it's more than 20, it's less than 30. You'd still have to do the math in case your answer choices are all like within that range, but it really helps you eyeball it. So here, we know, and now this is getting more into algebra, we're going to call this M. Why it's called M? That's just the mathematical placeholder that they use for lines. M is called the slope. Slope. Okay, so whenever you're going up like a mountain, I know here in the valley, it's pretty flat. Or you can also think of like the inclination, like whenever you're going up the ramp on the expressway. The curve upward or downward is called a slope. Kind of like when you're going skiing, the slopes or like a slippery slope, like if you're telling lies. So we call that a slope. That is called the rise over run. So that's basically the rise is like the vertical over the horizontal. So the rise is like how much you go up. Like you go up this way, and then you go this much that way. So this is your rise, and this is your run from that point. Rise and run, when I first was learning this, it didn't make any sense to me. Like, okay, why not run over rise? It ended up just changing the value completely. And a great way to remember is before you can run out of bed, you have to rise out of bed and get up. So you have to wake up and then you can go running around. Run over up. See? Rise over run. So you have the vertical distance, and then we divide by the horizontal distance. That is our slope. And another way to internalize it is, so let's say we have 3 different slopes. Let me see if we can see. Can you see up to, okay, I need to switch the camera a bit. There we go. So let's say I have two lines like that. And I need to climb one of those 2 mountains. This mountain is going to be easier to climb because the slope is not as high. It's a lot more gradual. So think of this mathematically, the rise over run. Since it's a smaller slope, I know the rise over the run is going to be a lot smaller compared to this one. This one's going to have a huge rise over a run. Because if our numerator is bigger, our overall value becomes bigger. If our numerator is smaller, our overall value is smaller. Now let's say I'm really hardcore, I just want to like get real strong. I can go ahead and like for every amount or for like every 2 feet this way, I want to like go up so many more feet compared to this one where I'm only going up so many. And just for argument's sake, let me make these both distances the same. So a huge rise and a smaller run. Okay, so we went over the basics of what a slope was. So here it's asking, what is the rate of acceleration? Something else I need to explain. I know that this is going to be from the math high set, but like I said, principles of economics, also like principles of like velocity, time, acceleration. Those terms are really just like thrown around, and those might be like more science-based, but just for the sake of you not getting tripped up on the question, acceleration is velocity divided by time. So like let's say I'm going like 30 miles per hour because I'm in the school zone. And it's not school hours. So I'm driving 30 miles per hour. And then the school zone changes to, the speed limit changes to 50 miles per hour. I'm going to increase my speed I'm not gonna like go from 0 to 50. I'm gonna go from 30 to 50. So from there, like how much my velocity changes over a certain amount of time, how much time it takes me to get to that new velocity, that's gonna be my acceleration. There's something else that you might feel. So like if you're like when you're driving the car, you start your the car's off, you start going. You're going at a certain velocity, it's even, right? Oh, if you're a brand new driver, or you're driving with someone who's not a very a careful driver, you might like when they brake or like whenever they're making turns, you might be going like this, like if it was a roller coaster. That might be showing that you're more they accelerate too much or too little. When you want to stop at a stoplight, you'd rather like decelerate, which is just a negative value. You're going slower, and you're doing it gradually. Like when you get to the stoplight, you're like this. You don't want to be that kind of person who sees the red light like floors on. You get whiplash. Just saying a little bit of extra information that way kind of like helps stick these concepts to you. So acceleration is how much faster than your current speed. Or in Spanish, ¿qué tanto vas a acelerar? Okay, so we see this. We see the rise over the run. So for this one, we also want to take into account what is our slope. And what's very interesting is whenever we have our ratios, we have our rise over run, but like let's say I have 3 over 4, my overall slope doesn't have to be a fraction. It could just be another value. As it could be a mixed number, or I could even write it as 0.75 for argument's sake. I can make it like that. But let's say we're looking at a problem and we want to like compare two different vehicles together. We're gonna have to get the slopes, the rise over run. Hey, that's a ratio. So we get a ratio of one vehicle, and let's say we have a different vehicle over here with a different rate of acceleration. Then I would calculate that rise over run, and now I have two ratios. What do I do with two ratios? I can assume that they're equal, where they're equal at certain points, and then I can then use a proportion to solve for any unknowns. Very interesting. So, word of advice is whenever you are going to be using proportions with slopes or these kind of graphs, do not simplify your rise over run just yet. It might just be easier for you just to leave it as is and like continue working your problem. But if you're really big adamant of just like tidying up all your numbers when you're plugging in, that's fine too. Just keep in mind that you want to internalize the concept of rise over run. Okay, so now we're going to be really starting in with the algebra. I want to really now dive deep into the number line. So here in the number line, we have 0. 0 means nada, zilch, nothing. Then we have 1, 2, 3, 4, 5, 6. These are called positive numbers. These are positive numbers. 0 is not positive nor negative. It is impartial. It does not matter. Kind of like, let's say you're having a disagreement and there's people who are positive, people who are negative. You can add by 0, you can subtract 0. It changes nothing. So 0 is not positive or negative. Excuse me. Okay. Let's use our negative over here. So we're going to be our negative numbers. And it's always going to be like this. Left is negative, to the right is positive. -1, -2, -3, -4, -5, -6. Something I do want to point out is the closer you are to 0, the smaller the value is, as in the absolute value of like this is 1. Has a distance of 1 away from the 0, so it's -1. Versus this -6 is farther away from 0, the same distance as 6 over here. However, between -6 and -1, -6 is actually going to be a smaller number because remember, to the left is even less. That's if you've ever heard people say like, you will sit at my right hand or my right hand of my table. Culturally, that's been with us for like a really long time. So when we started like making algebra, well, not we, but like people back in history, they would make this, and they just based on their cultural norms. So to the left is less. I'm so sorry if you're left-handed. It's just how it is. So something else I like to point out about positive numbers is that they have an invisible positive. It looks just like a plus sign, which truly, when you're adding, you're putting a positive value onto it. Or if you're subtracting, you might just be putting together a negative number. This really comes into play, like when you're using your bank account and you have maybe like $500 in your bank account from a deposit, but then like you made a $200 deposit to your or withdrawal for your rent. So like negative value is like money taken away from your account. Positive value is money being added to your bank account. That concept. Okay, so these are called signed numbers. Now that we have a little sign in front of them. So we're going to be adding and subtracting. I know this is really dull, but I really want to drive home the concept of two negatives are going to make a positive. So let's say I have 1 plus -4. What is that going to be equal to? So in the English language, when we look at math, we read from left to right. So we're going to start at number 1, at positive 1. Okay, so let's use a different color. All right, we are right here, starting point. And we're going to add, well, there's -4. So truly, we're going to subtract 4. This really means this. So we're going to move it 4 places to the left. So we're going to go 1, 2, 3, 4. So this is where we end up. Our value is now going to be -3. Ta-da! Okay, let's do one. Let's do 2 more. Let's say I have -5 plus 4. What is that equal to? Let's erase. We have -5. And we're going to go into the positive direction. We're going to move to the right because this is a positive value. And there's no other value. 1, 2, 3, 4. This is where we are going to end up, -1. Okay. So now we're going to use, let me do it up here. I'm going to do -2 plus -3. What is that equal to? The reason I'm doing a parentheses right here and right here is so that it doesn't get mixed up. You might not see the parentheses on the exam. It might draw it like this instead. Or have like a shorter minus sign. That's something that they're more likely able to do, like based on like the fonts or different characters they can use. They can also do it like that. It's the same thing. So here, really, it means this. So whenever there's a plus sign and there's like a negative, you can just drop the plus sign. And then you get this. It makes it a lot easier when you're simplifying. Let's move this. We have -2. We're going to start at -2 and okay, -3. So we're going to move 3 places to the left. 1, 2, 3. Our answer is going to be -5. These are all the same. Those 3 are the same. Something else I want to point out. And I think we're going to have to erase to make more room. Seems pretty fun, pretty straightforward, pretty easy. Sounds like we're going to knock this out. Remember, if you have a great foundation, you can then move on to the hard stuff. If your foundation is shaky, you're going to have problems down the road. So let's do -3 minus -2. All right, that's pretty interesting. So does that mean move? So I know this means move to the left if it's a minus, but over here I have a negative number. Does that mean no problem? Just keep on moving to the left? No, it means 2 negatives make a positive. Anecdotally, that might not be true, like an eye for an eye, but like if people say, I don't, like a little child will say, I don't want nothing. Truly, the child is saying a double negative. Same thing here. So whenever you see 2 negatives together, you can kind of imagine them being like this, and then going like this, and forming a plus sign. So we're going to rewrite this as -3 plus 2. Whoa. Totally makes the problem look different, but it's the same. It's the same thing. So we start with -3. Then we're going to add 2. That means move to the right. 1, 2. Our value is -1. Right. You know, I have a great problem right here. So let me go ahead and erase this. Now that we have the concept down, moving from left to right, are we going to add, are we going to subtract? This is a great problem. And it's a very practical problem too. Is at 2 p.m. the temperature was 92 degrees Fahrenheit. Excuse me. A coach observed the following changes over the next 2 hours. So degrees Fahrenheit minus 5 degrees Fahrenheit plus 6 degrees Fahrenheit minus 3 degrees Fahrenheit and plus 13 degrees Fahrenheit. What was the temperature at the end of the 2 hour period? Okay. So we know that at 2 p.m. That's supposed to look like a thermometer, is 92 degrees Fahrenheit. And over those 2 hours, there was multiple fluctuations in temperature. We saw the temperature rise 12 degrees, go down 5 degrees, go up 6, go down 3, and then shoot up 13 degrees Fahrenheit. Now, it does not say that all of these, like, oh, it was here for 5 minutes, for so long. No, this could just be like a shower passed by, like as a rain shower. Maybe a cloud passed by, maybe like hot air blew by. So that would cause all these different changes. If you're sitting outside, you'll notice the temperature fluctuates just very differently. So it wants to know, okay, so like after all of this, what was the temperature? So I'm going to need every number here to calculate it. So if we, at 12 degrees Fahrenheit, so we get 92 plus 12, we're going to get 104 degrees Fahrenheit. That was after, let me use different colors. Use plus 12 degrees Fahrenheit. So it went up. Then it went down by 5 degrees, so negative 5 Fahrenheit. We're going to subtract by 5 degrees Fahrenheit. we're going to end up with 99 degrees Fahrenheit. And just to keep track, I'm going to be scratching things out. Whew. Okay. Then from there, the temperature rose up by 6 degrees. So we're going to add 6 degrees Fahrenheit. It's going to be 105. Degrees. And then we're going to subtract by 3 degrees Fahrenheit. It's going to be 102 degrees Fahrenheit. And then we're going to add 13 degrees. That's drastic. So 102 plus 13 is 115. Oof, that's hot. I do not look forward to summer in Texas. It's going to be very hot. So finally, at 4 p.m., as I said 2 hours later, the temperature is now 115. So using this information, like the way that I did it in multiple steps individually, I'm able to see that the lowest it ever was in this 2-hour period was 92 degrees, and that the highest was 115. And I also know the temperature at each different point. I could even order these from least to greatest, find the mean, median, and mode, and the range. But the problem isn't asking for that, so I don't need to do that. And in fact, there's even a faster way of doing it, where I can just like beep, 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 calculate it. So I can just do 92 degrees. And I'm just going to drop the degrees just to save me time from writing. I'm just going to say in Fahrenheit. Because all of the problem is dealing with Fahrenheit. So it's not going to be 92 plus 12. It's very cool. They already tell them it's plus or minus. Minus 5 plus 6 minus 3 plus 13. I can just go ahead and do that. And just type it all into my calculator. Or something very cool that I can do is that I can separate the negatives and the positives and group them together. So these are my negatives, then things with minuses, and I can just do this. 92 plus 12 plus 6 plus 13 minus 5 plus 3. Right? Because if I minus 5 combine it with negative 3, it's the same thing as negative 8. I could also rewrite it as negative 5 plus 3. Right, because all of this is going to be negative. It's like I'm multiplying a negative 1 and distributing it to the 5 and the 3. That's a little more algebra than I'm planning to go into in this single problem. So let's just write it like that. So negative 2 plus 12 is the same as 104. Okay, 6 plus 13 is the same thing as 19. And minus 8. Okay, much easier. I get 104 plus 11, which is the same thing as 115 and degrees. Whoa! Faster, easier to keep track of. And if I had the calculator, I could just plug it all in and just got my answer. Pretty sweet. Okay, so that's it for number lines. We're going to be moving on into other algebra basics like multiplying and dividing signs of numbers. So let me go ahead and erase. Okay, so since we're getting more into algebra, I'm not going to be using the x as multiplication, especially because since all this is becoming digitized and camera quality, your phone quality, the way that you might be seeing this, might just look too similar to the curly x of unknown, especially if I'm writing really quickly. I'm going to be using a dot to multiply instead, or I'm going to be writing like this. This means multiplications. I put like 4 times 3 like that. That's a lot of extra keystrokes. I could just do this. One way that if you start doing like mathematical operations, like if you're like Googling or like searching, you might notice that like if you use the little star symbol, or that's how it appears on some calculators, the star symbol when you type it in, you might get that. So let's go into multiplying and dividing signed numbers. So numbers with like minus and like plus sign. Okay. Something else I do want to point out is that you can write division like this, the division symbol. But a lot of time on your phone or on so many calculators or even on your keyboard, there's not a specific key designated like this. We do have slash, which is the same thing as a fraction, because like 1 divided by 2 is the same thing as 1/2. If I write it like that, it looks more like a fraction. But it's the same concept, you're still dividing. Okay, let's get into it. So let's say they're asking for us how to write something worded out like this. (20) divided by -5. So let's say the question says, I want you to convert this or write the equivalent but in fraction form. 20 divided by -5. So the negative is going to stay right here. However, so like a positive and a negative, whenever you put them together, you're gonna end with multiplying and division. When you get a positive and negative together, the negative will overwrite anything. It's like if you go to a party or like you're on like a vacation and there's like one party pooper, they can mess up the whole party for everyone. And I mean, there's just one person. So like everything will become negative. So really come like this. And of course I can always simplify this too. Truly. Now let's say instead it was asking for -20 divided by -5. Well, misery loves company. And party poopers tend to like other party poopers, if you haven't seen. People who like to complain a lot, they love to complain with other people who complain. Now, if I'm dividing or multiplying and the numbers are the same, it ends up becoming positive. It gets canceled out. Because when party poopers get together and they're all complaining, they're having fun in their way, at least. So it just becomes positive 20 over 5, which just becomes 4 over 1. Same thing as 4. Okay, so let's do a couple more examples. If you have any questions, you're more than free to just type of questions in the chat box. Okay, so let's say it says multiply 4 by negative 25. Alright, so here the signs are different. The sign here is positive for 4, over here for 25, it's negative. So positive, negative, the negative's gonna ruin it for everyone. So we're gonna get really negative 100, because 4 times 25 is 100. So that's our value, negative 100. You could even do it like this. Like, if you want to like not worry about like negative signs until like the very end, you can actually just do the math in here first, which is like this, and then I can drop the parentheses because remember it's like going to have one over here becomes negative 100. Okay. Let's do another question. So we have negative, negative, make it positive with multiplication and division. Not the same with addition and subtraction. With addition, the biggest value wins. If I have negative 100 and a positive 2, the negative is going to win. If I have a positive 100 and a negative 3, the positive 100 is going to win. With subtraction, the more that you move it to, that's going to win the sign. Multiplication, division, they both follow the same rules, as in negative and negative gets positive. One negative, like with a bunch of other positives, ruins everything and everything becomes a negative. So let's do divide negative 160 by negative 8. Okay, division. I see two negatives. When I'm dividing negative by a negative, I get a positive. Misery loves company. Scratch that out. I can rewrite this as 160 over 8. I can just go ahead and simplify this as 20 over 1, which is really just 20. And the way I did that is I divide 8 on both the top and the bottom. It's a little blurry. Yeah, that's better. Okay. That's my final answer. Okay. So let's do a longer question, because these are very straightforward. But we've mastered the concept. So let's say we have negative 5 times 6 times negative 1 times negative 2. Excuse me. So negative 5 times 6 times negative 1 times negative 2 times positive 2 is equal to what? Okay. So there's multiple negative signs, there's multiple positive signs. Like we did in the previous question, we can just deal with the actual number first, and then we can deal with the signs. Or you can group them accordingly and then do your work. But let's go through this. So let's just do 5 times 6. This really just means multiply by 1, by 2, by 2. Alright? So I could just simplify that as 5 times 6. Same thing as 30. Why do I bother rewriting 1? Anything times 1 is 1. 2 times 2 is 4. So 30 times 4. 6 times 2 is 60. So then it's 120. Okay, I'm not done yet. Remember, signs. So how many negative signs do I have? This one, 2, 3. So I have 3 negative signs. And I know I can just say this without a doubt, is I know this will be negative. Here's a neat trick. Odd number of signs it's going to be negative. If there's an even number of signs, the answer is going to be positive. Let me explain. Thank you. Is if we have, think of it as like a superhero. If there's a super villain, that's going to be balanced out by a superhero. They're going to fight. But let's say there's like some other person who doesn't have a match. You can't cancel those things out because anything that's even are like values like 2, 4, 6, 8, 10. They each have their pair, so they cancel out. So here we have 1, 3, 5, 7, 9. All of these they're going to have 1 extra. So here I get negative 5 times negative 1. I end up with a positive 5, but then I have a negative 2. So a positive times a negative would equal negative. This is very common, especially with party poopers. If you've ever hanged out with people and there's 2 people who are usually party poopers, like negative numbers, but they actually are able to agree on something. They become kind of like positive people. But then like a different kind of party pooper joins and like ruins their fun too. So then that's a way to remember it. So like if you have an odd number of signs, like there's not like a buddy for a negative, the negative is going to ruin it for everyone. Here, misery has company. So like the negatives are together, they're fine, they're balancing each other out, you get a positive answer. Here there's 3. I know I said that the 1 doesn't really matter, but this is a negative 1. And negative ones will always become the opposite. It's kind of like frenemies. Okay, so let's do some with division now. We did a lot about multiplication. So let's do a combo problem. And no, I'm not talking about like a double cheeseburger with large fries and a Dr. Pepper shake. Talking about using multiplication and division. You could say, oh, I'll just type it all into the calculator. And yeah, you do have calculators that will like neatly organize this. If you have like a graphing calculator, or if you have your phone and you're typing it in, you might not have this option, but if you like rotate it, you have the option to like manipulate the fractions to be more visually appealing and easier to type in. But let's just go ahead and just simplify this. Let's use our human brains. If a human brain was able to design the calculator, then we can solve this problem. We have -4 times 6, and then we're subtracting by the quotient, remember division, we call this quotient, of the sum of 3 plus -9 divided by -2. You don't have to remember like the terminology that I wrote this in, especially I believe the captions might get a little messed up. I might have to go in and edit the closed captioning on this video. But let's simplify this. Okay, so we're going to do this chunk by chunk. So this is a very easy chunk to deal with. So -4 times 6, we get with -24. Okay. Minus. This is another chunk we can deal with very easily. So 3 plus -9 is the same thing as 3 minus 9. So 3 minus 9 is -6. Okay. I'll leave the -2 the same. I don't want to get too caught up on myself. Excuse me. This is the case with questions like this. Someone might say like, oh yeah, -6, -2, and like they'll like your mind might just go faster than what your hand can write down. It's happened to me before. And it could cause errors, especially when you're dealing with signs. Just like take it easy. If you gotta just do one more keystroke, hand stroke, you'll be fine. Okay, so now we have -24 minus. Okay, so let's deal with the inside right here. Okay, so, woo! So here I'm seeing it isolated right now. And I see negative and a negative. Hey, they're buddies. They're happy. They become positive. Okay, so this is the same thing as a +3. There's a negative on the outside. Remember that. You are not seeing double. You are going to write it like this. Okay, it makes a little bit more sense when you do it like this. Then you can further simplify it into this. And so let's say we're starting on our number line. And right here we have 0, and over here we have 27. Since this is a -3, we know we're going to go even further away from 0. So we're going to be over here. So our value, 24. Our value is actually going to be -27. This is our final answer. Ta-da! Something else I want to point out is this. I could have written the -4 and the times 6 like this. Just extra info. Just in case any of you are skipping back later. This is the same as this. Same thing as whenever we choose to write it like that. All of this is the same. This does not mean -4 plus x. Here we're using the parentheses as multiplication. Keep that in mind. So next we're going to be going into powers and roots. This is a good time for break. It has been 1 hour of lecture, so we're going to go for a 10-minute break, and then we'll come back and talk about powers and roots. So let me on break for 10 minutes. Check the time. Right now it's 7:15, so we'll come back at 7:25 p.m. Right. And we are back. Well, I guess it looks clean enough. Okay, powers and roots. So, powers is just a different way of explaining. Oops, sorry. That's better. Powers are different ways, is a different way of expressing multiplication. It's a shorthand for multiplication of the same value if repeated number of times. So if I have 2 times 2 times 2 times 2 times 2 is 1, 2, 3, 4, 5. We're multiplying 2 by 2 5 times. So it's like 1, 2, 3, 4, 5. Let's see. I think that 3 looks a little blurry. There we go. We can just write it like this. So the last value is a 5. 2 to the power of 5. These two equal the same thing. Pretty cool. It makes it much easier, like when you're writing things down, especially if you're dealing with like higher values. Like if you're dealing with for one of our students that wants to go into IT, like two-way security or encryption methods, they have to use bases of 2, or for like making like computer networks, they have to use bases of 2, which is like the bottom value, and then using different powers to determine like what network they're going to be using. So like if it's like to the power of like 8 or like 18, I don't want to write 2 times 2 times 2 times 2 times 2. It's going to be very difficult. It's very prone to error. And you can write this in some calculators. It lets you do that. But let's say we're typing this out and we don't have the fancy Microsoft Word formula. We can just go ahead and also write it like this, like a little caret. That 5. So you might have seen that in your keyboard. Let's see, where is it? On my keyboard. Oh, yes. So if you look at your keyboard, if you're in front of a computer right now, you can look at number 6 and that little caret like this. That is the symbol for power, to the power. So you can type it like that. Something else I want to point out is, why did I put a 1 here? Like, well, when I'm multiplying 2 by 2, I'm multiplying the number twice. So if I have 2 to the power of 1, let me erase this. So let's say I have 2 to the power of 1. It's just 2 to the power of itself. Remember, whenever we multiply by 1, we divide by 1, we get the same value. The same thing with powers. It's going to be the same thing. It's going to be 2. But what if I do to the power of 0? Interesting. This is very interesting. I actually get 1. Any number to the power of 0 is 1. If I do 95 to the power of 0. I know that looks like a degree, so I'm just going to go ahead and write this out as to the power of 0 is going to be equal to 1. Any number to the power of 0, and just for clarity's sake, for those of you who may not be following me or like trying to go through the video very quickly, I'm just going to go ahead and just write it out in this form, just for the sake. And this is another way of writing 0, just so it's like more visually distinguished. It's going to be equal to 1. So let's use a... Now, what if it's a negative 2? Ooh, that gets really interesting. So let me go ahead and erase this. So powers is just a shorthand of multiplying that value a repeated number of times. So we discussed whenever we have a power to a positive. This. Very easy, very convenient. When we have a value to the power of 1, it's the same number. Number to the power of 1 is the same number. And if you forget, your calculator won't. That's the beauty of it. But any number to the power of 0 is going to be equal to 1. Now let's go over negative. Negatives are very interesting. They manifest very, very differently. So let's say I have 4 to the power of negative 2. Dun, dun, dun. When you have a negative power, you're actually going to have a fraction. I'm sorry, my voice went really high. So we're going to have 1 here. We're going to have 4 at the bottom. Because there's no other like value, we're going to just have 1 as our numerator. And remember how I called this 4, or the numbers here? That's called your base. This is called your exponent. The base, okay, it sounds like it's the base for this. The base of a fraction is the denominator. So the 4 is just going to become the denominator. Now, the 2, it's no longer negative because the negative already like did its job in converting this into a fraction. So we're just going to carry the 2 on without the negative sign. Interesting. Well, we got to simplify this. So 4 to the power of 2 is 4 times 4. Right? So 4 times 4 is 16. This is my answer. Pretty cool. So if I don't want to write a fraction like this, I can be real clever, really clever, and do a negative exponent. This again is very helpful when like calculating certain things. Instead of having to put like 1 over x or something, people can just do x to a negative power. It's sometimes a lot easier seeing it and typing it out multiple times. I remember whenever I have to like type in formulas into like Microsoft Word, it's very painstaking if I want to make it look pretty, but it's a lot easier to make this look pretty in a rich text format, which is like a very common underlying document format for a lot of word processors. Okay. So something else I want to point out about powers or exponents is that you might hear something said, the power of 2. So like this is a specific power that has a special name. So the power of 2 is called squared. Now this is very important because our next section is about roots and square roots. now this is where everything's gonna like tie together. So power of 2 is squared. So if I say I want to build I want a garden with an area of 5 to the power of 2, or 5 squared feet, and since feet is in an area, it's feet times feet and squared, I'm going to have to do it like this. Also, I'm going to have to make it equidistant, because if it's a square, each side is equivalent to each other, and knowing that a square is power of 2, I know that the length and the width are both equivalent values. Wow, so you're introducing all of this like background knowledge together and like building these concepts. So that would be the garden. So in some calculators, some scientific calculators like the Texas Instruments or even some Casio, you might see a little button that looks like this. So instead of you writing or typing in 5 times 5 in the calculator, you could punch 5 and then like punch in that curly x to the power of 2. It's going to basically do this. And all of this is the same, truly. Ta-da! Okay. Oh, which, by the way, this is 25 feet squared. 5 times 5, 25. Now let's say I wanted to make like an elevated garden bed. This is where my drawing skills become much more taxed. So let's say I'm making like a compost pile. I'll make it a cube. Let's assume it's a cube. Haha. Let's see that. 5 feet. 5 feet. And 5 feet. So power of 3 cubed. Because it's equidistant. The length, the width, and the height are all the same value. So here we're talking about area, right? Sorry. We're talking about like length times width is area. Now here we're talking about volume. So this is how you know, like if you ever get like a question, like we don't want to just like cover the surface. We want to like fill a container, like a cup of water. I'm not just talking about the area of like how big of a lid I might need. I'm talking about filling this whole container. So here, I'm going to do 5, 2, 5, 3. So not only is it going to be 5 times 5, it's going to be 5 times 5 times 5, which is 125. But since my units are in feet, here it's going to be feet cubed. Feet, I'm not talking about like your feet with toes. Your feet are going to be multiplied 3 times because the 5 was also multiplied 5 times. Great way to know if you're just looking at these numbers, let's say you become an engineer, and you're looking at 125 feet cubed, and then you have 25 feet squared. Like, okay, which was the value? Like, how much mulch do I need to like fill my compost pile? You can just look at the unit. The unit's gonna tell you, is it volume or is it area? Power of 3 cubed, volume. Power of 2, area, because it's squared. Okay. Now, if you have a question about like in the calculator, how can I go ahead and write my exponent of the power as a negative? So this is very relevant for you to know how to do calculator skills. But even if you forget like the right keystroke pattern, that's fine because you know the concept and you can just do it in little chunks. So let's say I have 4 to the power of negative 2. Some calculators have the little caret, and you can just do this. And it might actually, when you type in the little caret, it might already put like the parentheses with it, and then you can just close the parentheses or don't. Just be very careful if like you're plugging in a lot of information to go ahead and close your parentheses. Also, in the some Casio models, like if you press, it'll actually like shift the little blank over here, and then you can just type in your negative 2. Very great. That's why I love Casio. Some of the more advanced level, like the Texas Instrument, like the TI-83, TI-84, they also let you do things like this, but not typically. They typically want values like this. But let's say for the TI-30XS, which is a very common calculator that you might use, multi-view. I'm not sponsoring calculators. I'm just showing you knowledge is power. So you can type it in for this specific calculator. It's actually going to want an extra parenthesis. Ta-da. So in order to like have the value multiplied, this is very different from this. This is negative 4 squared. So if you have, if you need to do like a negative 2, don't use this button because this button is assuming a positive power. So if I accidentally do this, my value is going to be very different. Because if I have negative 4 times negative 4, I'm going to get negative times negative cancel out each other. I'm going to end up with a positive 16. That is not the same thing as this. 1/16 and 16 are wildly different answers. If you can't use your little shortcut, don't stress it. There's even been times where like I'm so used to using the little caret, and like even if it was to the power of 2, I might not even click this button because like it's like a very, it's not a one size fits all solution like this one. This is very niche, very specific. Just food for thought. Next, we're going to be getting into roots. Woohoo! I remember the first time that my father was going through an electrical manual for a new AED, you know, what you use to help knock out someone's heart rhythm, like when they go into cardiac arrest. I think I was in high school, and like they were implementing this. All of the like the ambulance divisions like wanted to implement this new Grate device, and they wanted them to go over like this large manual for their meeting, and there was like problems for them to do, and like this was going like deep nitty gritty that like a lot of medical professionals don't really need to go into the nitty gritty of, and there's questions like all on this book, and he's like, hey, like this is really weird, and like you're really good at math, and like these questions, it asks for me to do them, but it has little check marks already. Why is it asking me to do the question already? Like, Dad, those aren't check marks, those are square root signs. He just said this was the book. This was a manual per se. He's like, square roots? What's that? It's like, yeah, it's like when you're like the opposite of a power, like when you multiply number by number, but it's like doing the inverse. I'm going to bed. And he shared this information with all of the other medical professionals. They said, oh, okay, so like this manual was not the right manual. This was more for like a technician instead of a medical professional manual. So that's just very interesting how the square roots are out in the wild, and we need to let people know that the little root symbol, square root, that is not a little check mark. So a square root is like this. You might see others that are like this. We'll get into that. So with this one over here, there's an invisible 2, letting you know that this is a square root. It's just once. Just like how we have our curly x right here, to the power of 2, it means x times x, right? Now here we have a square root. So let's think of a number times another number that is yet another number. So the square root, excuse me. So the square root of 144 is equal to 12 times 12. So I'm actually doing it backwards. Isn't that amazing? So like 144, because 12 squared, right? 12 times 12 is 144. So square roots and power of 2, they're like twins, but like they're opposites. See, so we have our 14 right, 144 over here, and we're talking about our 12 right here. That's amazing. So we say right here in words, the square root of 144 is 12. Now, sometimes you might be asked to calculate a square root, and it might not be a whole number. You might get like 12.5 times 12.5 might actually ask for like, you can even do square roots of non-whole numbers. Like I can do the square root of 4.5, but I'll get like a really long repeating number, or it might be very difficult. something else I'm going to point out is negatives also show up here. Because we know from our like previous little section that like a negative times a negative is a positive, well, these numbers are being multiplied an even number of times, right? So technically, negative 12 times negative 12 is also equal to 144. This is where I remember when I first saw this, I was like, what? A whole new like mathematical universe had been like exposed. We'll be getting more into this later. I know for the GED, they don't expect you to be like looking for like the negative squares, but for the high set, I just need to go ahead and just double check because we will be using these negative values somewhere along a little later in these sections for algebra. So I just want to double check with that because there have been some changes to the high set. Still no update of when we can test, but I will let you know as soon as possible, like the minute they tell me. I'll send out like a mass email. For real life though, like let's say I'm asking like the square root of, I have 144 units and I want to divide them equally. What's the size of each unit? I'm talking about like real things in real life. I'm probably gonna go with the positive value. I can't really say like negative 12 units. Like doesn't really work. So always put the perspective of reality over math. Like if any of you have seen like the Matrix movies, it's kind of like just like this whole other world, and then you gotta like layer your reality on top of it. Okay. So the next section is on scientific notation, and I think that'll be like kind of like a great little like recap of today, but we're gonna do that tomorrow then. It's great, it's great. Okay. So I'm just gonna finish the day by just showing you how to put this into a calculator. In some calculators, you might already have the button for a square root, like that. And in some of them, it might actually, when you press that button, on your screen, it's going to appear like this. And then it's going to like ask for you to enter a value. You can enter a value. You can close the parentheses. Really recommend you do. Good habit. And then you can find your square root. Well, so let's do one more square root. Okay? So the square root of 25. 5 times 5. Square root of 9. 3 times 3. Woohoo! Pretty cool, pretty cool. If you were like a big superstar in elementary school with your multiplication tables, dealing with square roots might be a little bit more intuitive for you. If not, square root symbol is right here on the calculator. Let's say again, the TI-30SX multi-view, because that's a very popular calculator that can be used in a lot of high school equivalency exams. You can actually press the second button. That's literally the name of it, second. Think of it as kind of like the shift key, like on your keyboard, like where you have the numbers at the top of your keyboard, and then you have like the little symbols directly on it. And if you want to get to the symbol, you have to press like the shift key. Same concept here. If we had a big calculator and only one button per thing, we'd have to carry a huge thing, and it'd be very inconvenient. So this is their version of shift key. It's called the second key, and then you can press the x squared, and this is notation for a square root. Make that easier for people who are scrolling through the video. So that is it for today. I really want to thank you all for checking in, and I will be sending out a midterm. Now, this midterm is open book. You have 2 weeks to do it. And then the last week of class, I'll go ahead, as soon as you give it to me, you can I'll go ahead and grade it. If you want to do like question by question and send it to me, that's totally fine. It's just to see where we are, knowing what areas I should be covering for the review on the last week of class. The last day of class is June 2nd, and we'll continue to meet until then. So have a great rest of your evening. Bye bye.